Okay, so in this series of videos, we're going to go and classify the stability of the origin. And the idea is that the origin is a equilibrium or a steady state, because if you were to substitute 0 in place of the x's and the y's in the differential equation, both x prime and y prime would be 0, which means that there's no change in the system, which means it's at rest or equilibrium or steady state. A lot of words there. All right, so to do this, we're going to go through and just look at the matrix A, which is equal to 6, 1, 4, and 3. And we'll find the eigenvalues by once again subtracting lambda off of the main diagonal and doing some algebra to solve for the values of lambda. So we're going to have 6 minus lambda multiplied with 3 minus lambda minus 4. That works out to be 18 minus 6 lambda minus 3 lambda plus lambda squared minus 4. Okay. And then this simplifies down to, it's like lambda squared minus 9 lambda plus 14. And so now if we factor this, we will get a lambda minus 2 and a lambda minus 7. And again, this is always equal to 0 this whole time when we find eigenvalues. So our two eigenvalues are lambda 1 equals positive 2, and lambda 2 is equal to 7. Those are both distinct real numbers, and they're positive. So because of that, we know that we're going to have a source node. And this quick sketch of behavior would be for us to have our two eigenvectors where the motion is away from the origin, and then we're going to have all of our solutions going away from the origin, like so. And again, if you were to go to a phase plane program, you could actually see this happening with the solutions getting larger and away from the origin.